So thanks for everyone who showed up, and thanks for Dan for having me here with the .NET meetup here at Intelitech. Do we have like a things that we do, like any meetup slides? I don't have those. Okay, okay. So we're just going. Don't have any meetup announcements. Okay, okay. I am excited to talk about Microsoft Orleans. It happens to be a good time to talk about Orleans because it seems to be getting more and more development love from Microsoft right now. I'm not incredibly familiar with Orleans, and I've been diving into it recently, and I appreciate the opportunity to kind of talk about it. Just to like improve my understanding of it and skills. And I hope that at the end of this talk, oh, I should, yeah, well, I'll say, I hope at the end of this talk, you guys also get an interest in Orleans. But a little bit, I guess we do an intro slide. I'm Austin Frostad. By day, I work as a backend dev at Safeguard Equipment out in Post Falls, and we do emergency response and safety equipment for utility workers. So it's a pretty fun job. And then at night, I work as a front-end dev with my wife as part of Frostad Studio, a little business we have. And so we do, well, we'll do brands for software, and then we'll implement the brand in the software. So I like doing that. All right, .NET Orleans. The motivation. Oh yeah, so yeah, the purpose of this talk is and discussion. I hope we have some good questions, and I hope I'm not just blasting out information as I'm still trying to understand all the concepts myself. But yeah, I want all of us to kind of understand why we might consider it, understand some use cases, why you might use it in your solution, increase its credibility among distributed systems options, and as well as understand enough of the fundamentals to get going and some of the pitfalls so that when you get going with it, you're not as frustrated with it. So they like this. I saw this somewhere when I was looking up images about .NET Orleans. You're still ignoring Orleans, and it's because it is the actor model that quietly powers Microsoft system. And so I thought that was kind of a fun screen grab because it's kind of the odd duck out. What is Orleans? So let's start with that. Where does Orleans fit in our .NET ecosystem? It is primarily fitting in here in the cloud and web development portion. And so you can think of it as another framework that you get to use like ASP.NET. And often it's used in conjunction with ASP.NET. So it can really improve your ASP.NET services. And here's how it works. So let's just talk about ASP.NET, right? A typical model for your architecture is you have, a command and control that goes all the way down to the database for state. So whatever the user does on the front end, they make a request, it's going to go through your logic and go through into the database. And prior to handling that request, you're probably going to have to check on, go do some reads from the database about, is this user able to do this, et cetera, et cetera. So there's lots of, I'm saying database because there's lots of reads and writes to a database. And so that means that in order to get state for your request as it comes in, right, to your app, because we don't know which instance of your app is going to be handling it after it comes through your load balancer, you have to go to the database, spin up a bunch of state, do the action, save all the state again. And then, so there's a lot of, that's nothing wrong with that, but it becomes an issue in some situations, right? So there's nothing wrong with that. It's just that Orleans is going to help us solve some other issues. So let's say you have a lot of updates to one resource. This is a really contrived example and terrible graphic that I made. My graphic skills are a little limited here. But you get the idea that you have a bunch of players or something, they're broadcasting information updates, they're coming in, you need to update a score. Well, you could do that in your application layer. You have to read from the database, get the current score, and add to it. Well, if you have many people doing that, obviously you see it's not going to work. You're going to have locks, you're going to have some sort of, you're going to have concurrency issues with this information. And obviously you probably wouldn't choose this architecture in this case. So what do you choose, going forward? But as my contrived example is, we have a team score, things going on, we need to update that score. And if you have a lot of requests, then your database is inundated and you're probably needing to find something else. So you might move to, let's say you had read heavy operations that you had a lot of state and you built it up for a particular thing and you could read it by caching it. So one of those things is you can have a cache layer to reduce load to your database. You can use optimistic concurrency with when you're just like sending things to the database. You can use database level locking, right? You can turn to stored procedures. There's a lot of cool features you can use on databases, especially like Postgres, to handle some of these issues. But as you continue to scale, you might have issues where you just have higher latency, lower throughput, higher database costs, because you're going to have to increase the, how much your database throughput is. You have to pay more for it. And then you have the cache infrastructure costs. You're going to pay for caching. And then you have to write more code every time you want to do something with the caching, right? So instead of just writing to the database, you got to write to the cache. You got to check the cache. It's not there. Classic examples. So we got the idea. You're starting to build up a system, a solution that requires, faster reads, faster writes. And that's just one of the parts that Orleans helps with. So I also want to think about, like, how would you build with ASP.NET an AI agent? It's really not just doing CRUD. So just continuing thinking about use cases for Orleans before I kind of describe it more. So like an agent though, let's think about an AI agent. It needs to react to inputs. It's got stream output, cancelable. We all know about different, the cancel operations we can do, right? And with every chat. Loop, retry, and then it's inherently stateful. Like you can go in and you can interact with this agent. It somehow has all the state and context from the last time you were working with it. That's kind of a autonomous system, but it's just magically living somewhere. But clearly not just running off a database. And so I just kind of spun up a little architecture for AI session, agent session here. These are a lot of things that are going on. And hint, hint, the Orleans team is making a template to build agents. So that's something you can do. We're not going to get into that because that's a little more above my pay grade right now. But it's a cool, they have a template going right now so that you can start building your own little agents. And well, it's kind of, I'm not super familiar. The example I saw was like interacting with your favorite LLMs. Yeah, and it was a chat client, like the basics for a chat client where that was the template they were showing, so you could, do some chats. It would save your state, start streaming back things to your front end. I think the front end was in Blazor too. So, but that goes to say, like, if you find yourself implementing things with caches, queues, and you need, maybe some durable execution tooling, you might consider Orleans. So let's go look at what Orleans is. Zoom. Simply, one of the ways, so the definitive definition of Orleans is a distributed virtual actor framework, which is kind of a mouthful, so we'll go with that. But I like the idea that it fuses your caching with your application layer. And so this gentleman I'll talk more about in a second, but he did his presentation. I like this graphic, just showing what we were just talking about, hitting your caches and stuff. Instead, we're going to build with Orleans, you build a system that allows requests to come in and get routed immediately to another service that has that state. And that state, like if you want to persist a database, you can control when it does get persisted, but it lives in memory. So So virtual actor is part of the virtual actor is essentially a virtual actor is a unit of compute with state. And in Orleans, we call those grains. So I'll get into that in a second. But the virtual actor is the the part with it's like you don't have to worry about any of the maintenance. It's an actor. It follows the actor model. So where you have these identities, you can work with these actors. So they, like think of them as services, but you don't have to like worry about any sort of management of those services. They're just virtually there. So you just say, "Get me my service," and no matter what app instance you're in, Orleans is going to coordinate and figure out how to get you access to that thing. So beyond a service, it has state. So it's a unit of compute with state, and then it's distributed, right? Because it has, you can access it virtually on any of your apps. So I wanted to get more like a concrete example with that, and I hope this, if anyone has questions, maybe this will help. So I have, let's compare a traditional implementation perhaps of like an auction, like if you were to implement an auction. This is really contrived. So, but if we have it, we're gonna have to, we have a place bid, we have an auction ID, bidder ID, and an amount that we want to add. So we come in here, we need to load in the state of the auction from the database. We need to get the bidder, verify that the bidder, you know, something about the bidder, but we need to get the bidder's ID and confirm it's actually a bidder, or you know, they have an account. So we're reading from several rows here, and then we're gonna validate, try to save it. And this is where the complication kind of comes in. If you're doing this, is if you're trying to save and you had a lot of people bidding on something, you're gonna have to worry about what, you know, what instance of your service, how many people are talking to the database, right, at once. And so you still have to write to the database. You need to ensure that they're still the highest bidder, because after the write, there may have already been a higher bid in the database. And so then you have to do that. So there's a little extra logic there. But imagine if we write it with Orleans, the features that come with Orleans here. I just have just a method. We'll get into like how that is actually implemented. But we have our same method, place bid, but all we do is state is already in memory. See this magical state object here? And we just check if the auction is open. We check if it's better or higher than the current highest bid. Create the bid, and we add it to the state, save the state, and return. So, one interesting thing you'll notice about this is place bid, there's no concurrency checks. That's because with Orleans, by default, in here, within this method, which is on a grain, but we'll get what the grain is, it's only one caller can come in at a time. It's single threaded. So it makes it really easy to manage your concurrency across all your system. And I think that's a really cool feature. And if you get crazy, you can do interweaving of your calls. You can turn on a option and allow, or sorry, interleaving. You can turn on interleaving, but that's only if you're crazy. But there's certain states where you may want that for various reasons. But by default, every time you make a call to one of your grains, which we haven't talked about, sorry, you get this wonderful, simple code because you don't have to worry. It's just a single thread. You know, no one else is going to come into this during that time. Yeah, exactly. So yeah, you can use various providers. So we'll get to that for the state, but essentially it's automatically populated, and it on activation of the grain. You just get that. So we'll go into what grains are. So so what we were looking at there was code in a grain, a method on a grain. And grains are the virtual actor abstraction in Orleans. and you have tons and tons of grains. So you can have a grain represent anything. So in that case, it was representing an auction. So you get to think you get to think about an auction as this living thing in memory versus rather just something in the database that you pull out. So that's what you can think of a grain. It's just a thing that you can work with in memory. It's living. It has a life cycle. But specifically, it has state and behavior. So it has the state. We can do methods that have behaviors. We can also have side effects. They communicate asynchronously with other grains and services. So you can call into them. They can call other grains. You can pass grains into grains. And they add some other cool features such as timers and reminders. So we'll get into that. The persistence capability, which we were talking about with state, like if you had an auction and obviously an auction can be represented in a database row, right? It has an ID. You can, on activation, go once, read from the database, populate that state from your database, and then you can automatically persist it with that write call that we were looking at. So if we have grain is equal to identity plus behavior plus state. Let's see here. On my notes. Great. Let's ask some questions. Mm-hmm. Yeah. Yeah. Yes. Yep. Yep. Yes. Thank you. Yeah, the question was just asking about like, what if you have many auctions? So if you have another auction, what defines, is there another grain for that other auction? And yes, it's identity based, Kevin was getting at, because grain is equal to identity. So every time you have a new auction ID, that in your system, it would just spin up another grain for that, representing that auction. So now you have these auctions that are just living in memory and virtually accessible from all your applications. Mm-hmm. Oh yeah, so we could talk about the how that works. So yeah. So the typically right, if the thing that houses, we'll talk about the host process. That's how hosting the grains. There's some failover scenarios, how things work. But yeah, you want to be strategic about how often you're saving, and sometimes it'll open your eyes to like, hey, I actually don't need to save very often. You can do a lot of things that are in memory. But yeah, you definitely want to make sure the grains are hosted such that you can write logic that to have failover situations. So if a grain did fail, or sorry, a silo, that's what hosts the grains. Haha. It's just like farming analogy. So yeah. So of course I was getting to the silo, but we could talk a little bit more. It is something that if when you're new to Orleans, you get paranoid about like what happens if the silo fails. But there's options for handling that. Plus, you have many silos. So. Mm-hmm. Mm-hmm. Oh, yeah. Yeah. So no, you would write your own provider for saving, and yes, that would complete the call to the database. So if you're somehow working in EF core, yes. Yeah. In this case, they definitely because it's Microsoft, the saving often is advertised. Use Azure Table Storage, Azure Blob Storage, Cosmos. so um, yeah, go use those ones. So They definitely have providers for those, and they make you do a little bit extra work for the other ones, but you can still use other ones. So it's making me realize. Okay. So as Kevin duly noted, grains are maybe I'll go to example and code just to solidify that how that works. Yeah, let's go here. Talking about how new grains are created programmatically, or how are grains activated, and where's that ID come from? So I have a simple endpoint here that it's going to go for placing a bid on an auction. So this is placing the bid on the auction, which is the code we were just looking at. You use your iGrain factory, and you can grab a grain. So notice, like, it's pretty cool. And then you get like this grain that appears to be just an object in local memory, but it's not. You're going to use a remote procedure call to work with it, because it may not be on the same, like in this case, this actual app is just separate from the Orleans instances, but it's gonna we can call a method on our bidder. So we got a grain for our bidder. So iBidder grain, we pass in the ID that came in from the request. That will create a new grain, and that grain will be activated on a silo somewhere. Yeah. So this very simple definition, so it allows you to abstract away the Orleans stuff from your client apps. But the one thing that's important is the iGrain with integer key. So this is the ID. This is how Orleans is going to figure out how to, create the identity, and basically this URL. It's like they talk about it like a URL to get that bidder, or this ability to remote call it. So yeah, so we can validate our bidder. Basically, if this, for example, if you passed in a bidder ID, and you would have to handle this is contrived code, but you could have a method in the bidder, and I think there is one. So let's go to bidder. Where's our state? Okay. This one's bad example, because it's just gonna create like, oh, here's a perfect example. It's not the best example. Basically, right here, this state, when it gets initialized, it's coming in with the bidder ID. You got some state. Your persistent state provider is going to try to use that ID to go get a bidder. But what if it didn't exist in your database? Well, then you'd be stuck with a situation where you can just kind of you can look at your state and be like, oh, there's no ID on my state. So it'd be defaulting to the, where's the bidder state? I purchased the bidder, yeah. So it would be string.empty, right? And this would be false, and this would be 0 for the int. Yeah. So this is not the best example, and there's probably, but essentially you're gonna get a default object for that, for your state, and so then you would know that that bidder didn't exist. And so you could, if you wanted to, on activation, you could fail if you wanted to, like, throw an exception or something. But in this case, we're just going to create a new one, because or in this case, there's a mark as all this is doing is basically populating the state. So it's very contrived. That's not a good example, but you get the idea. Is that making more sense? Like the ID, and you can, if let's say if you wanted to call a bidder or create a bidder, you could call into it, and you could call create bidder, and we could add a method called create bidder. Like, I'll talk more, but then. So you could add a create bidder method, which then would populate the state, ensure that that bidder exists, and then you could write it to storage, right? So that's what it's going to do. Boom. So that's what you would call if you discovered that it didn't exist and you were like creating one in your Orleans environment. Instead of like saving stuff to the database, you would go through your grains. Mm-hmm. Yeah. 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 It could. Yeah. Yeah. No, it doesn't. Yeah. Yep. Yep. Yeah. Yeah. Create. Sorry. Create. Yeah. Yeah. No, I think you're getting at a good point with the architectures. If you're there's some things that you might write state for your grains just in a regular CRUD way, and then you have some other portion of your solution that's using grains to access that state. So going in and going like, oh, you don't have a bidding account, so just file over real fast. So I think that's probably what we would do here, actually, like what you're saying. Yeah, is you wouldn't go through this way, but contrived example. This is how you might like spin up new state for your grain. So now the next time this bidder grain gets called with the same ID, it would have these items persisted in the state. So, okay, good questions. So they have, so we're just getting the grain. There's an activation. You can tie into the unactivated async, and then you can do things in there. There's a life cycle. There's I think it's a default of, oh, I should know this. I thought it was, I think I changed it the other day. It was like on mine. It was like you could set how long you want a grain to live for without interaction. So every time a message is sent to it, that way keeps that grain alive. And so messages come in a queue. That's why we can work the message queue is in memory on the silo that's hosting the grains. So it's kind of an important thing. If you can lose messages. Messages are delivered at most once. So they're not durable. No. But no, I don't, there might be some way to, no, I don't know. I don't know about that. It's not guaranteed delivery, but because you're calling it with that await, you get feedback pretty much immediately. So there's a timeout too. You can adjust how long you want to wait for a call to work. So let's say a grain was on a silo failed, that grain trying to send that message, we're trying to call, place a bid to the auction, and then it's like, what's going on? It's gonna take a moment for Orleans to rebuild that grain on another silo. So maybe there's a window there where, but you would get an exception on when you're calling it. So, but it's good to know, is important to know that it is in memory. But for the most part, we're talking about like latency of 25 milliseconds. So, like when you're in your cluster. So, it's not like you're usually not having to worry about that. But important to know, in memory message queue, and that's why if you might have a concern, because if you have a hot grain that's getting a lot of messages going to it, like a lot of bids are coming in, well, you want to write your logic so it's fast, of course, but that's something where you could have the situation where something failed over. Mm, mm, mm-hmm, mm-hmm. So that, yeah, this message queue for grains is very essential, like the fundamental layer. But if you wanted to use a situation like that, you could use streams, and we'll talk about that. Streams are durable, and so you can use Azure, queue, and you can have those messages for sure be delivered. So at least once delivery versus at most once delivery with this. So when you can keep a grain alive. There's methods for keeping grains alive. Should have the code example, but it's like something something keep me alive. Yeah. So you could continue to keep your grain alive. Yep. So then this is a little more complex. This is kind of more of an implementation, but no, it has life cycle. There's places you can tie in. You don't have to use, like in this example, where with the bidder, we're using a persistent state injected in, which is really cool. But you can write your own, just write in the onActivate on grain. There's the activation. Oh my goodness, there's too many activations. There's deactivate on idle. Oh, there's a lifecycle one, right? You can tell it to deactivate. You want to, you can, oh, delay deactivation. There it is. That's the method you call, and you can pass in a time span, and you are pretty much you're pretty ensured that it'll keep the grain alive. So you can think about strategies around that based on, well, who's interacting with this? What's the frequency of interaction? Do I want to keep it longer? You know, maybe it's something that's used every 5 minutes, so it's like, but it's expensive to build up all the state in it initially. But 5 minutes is like, you know, like, oh, I want to, yeah, like, but it would otherwise be deactivated because it's infrequently used. Oh, there's a new feature, migrate on idle. That's a good one too. You can call this, we were talking about failover scenarios, or like, what's the upgrade path? Exactly. Yeah. So you want to spin up, you have new grains, you have a new build of your Orleans app, right? You can use migrate on idle and tie into that, so that, especially in Kubernetes, this works well. This is where you're mainly going to use that, is you can tell those grains specifically, all the grains on that silo, they're going to call migrate on idle, and then there's a specific spot where they want you to tie in to do that, but it's in documentation. It's called like graceful migration or something like that. So they added that new feature that, yes, grains can now migrate from silo to silo, and that's a really cool feature. Yeah, right? Yep. Oh yeah, there's so much activation, delay activation. Yeah, there we go. Here's our onActivated async. So this is also a place where you didn't want to use your own injected persistence provider. You could just call straight, you could inject in an EF core context or something. And I'm not sure how that, you have to be mindful of how that works. I'm not sure with grains, because yeah, how the threading works on that, I'm not sure. I haven't gone on that, but let's say you want to activate it, and I don't know, you can inject the HTTP client and call something, activate. You could spin up your state in whatever way you want, and that's kind of the lifecycle hook where you would look into that. Then, yeah. Mm-hmm. Mm-hmm. Okay. Yeah. Yes. Yeah. This one's saying, so I believe, so default right here it's being used the default storage provider for grain state. And that is being configured all the way upstream in our, I believe in our host, our app host. And then bidder, that's just saying this is the type of state. So that's kind of important for it. I believe these are going to blob storage. So all bidders will be put somewhere in bidder structure. Yeah. Yeah. Great. Good questions. Let's go back. So we covered a lot of things about the grains. And then I just will briefly talk about the silos, right? The silos where the grains are, that's where the activations live. grains can obviously move around silos. That's where the messages are processed, timers are run. And then a group of silos is a cluster. So yeah, I don't know what I don't know why why did they break with that. I'm sure that's been a joke of many Orleans talk. It's very confusing why they just didn't call it the farm. Maybe there's like, I don't know. I don't know. They only got so far. The silo and grain guy got axed eventually. He moved on to another project. So, yeah, so clusters are important. The important portion of the ecosystem, because that's like they support giant, the dynamic joining and leaving of, that's where the logic is managed of the silos. So if a silo goes down, there's this membership record and they go like, oh, like this silo's gone. So now what they'll do is, in the latest edition of Orleans, is grains are placed. We didn't talk about grain placement, but grains are placed strategically based on metrics of the hosts. So if you're running out of RAM, it's going to start putting grains on another place or memory, and then CPU, and then so if you lose an instance, it used to be like if you lost an instance and never came back on with a silo, you lost all those grains, and then like now a bunch of grains would fill up on the other ones, and then you would add a new instance. And then if you added a new instance, now you have a bunch of, you have fresh compute over here. You got fresh memory, but nothing would, only new ones would go there. Now it'll migrate and see that there's a new instance, and grains will migrate over there to load balance. So it's kind of a cool feature. The other part is, so here's a fun image. Grains going into the silos and the clusters. Mm-hmm. Yeah. Good question. Good question. I think, yeah. So I don't know. I don't have a good metric for that, other than it's pretty fast. They're usually like, typically you deploy these in Kubernetes, so it's as fast as a Kubernetes pod spins up on whatever your platform, and then yeah, it gets going pretty fast and communicates pretty fast. But oh, I gotta go back to this guy. He was demonstrating. So his name is Ruben. The latest feature they added is like locality aware placement, and there's a bunch of grains and they're just doing their things, but now it'll track which grains are talking to which grains, and then it'll repartition them across the silos, so for more efficient, faster communication. So that's a pretty cool feature. So we got grains that will move themselves around. This is a new preview feature though, so you do have to opt into it. Yeah, they're still ironing out the kinks. It's funny when you go look at the documentation for it, it has references to like papers behind the math that were involved. So they're definitely passionate about it. I was gonna go back to Ruben here. I would be remiss to not mention him. So Ruben Bond, if you look up anything with Orleans, he's like the lead dev, and this is his project right now. So he's really passionate about it, and yeah, he has great talks about it. So I guess most of the stuff I have and the documentation and everything is like pretty much stuff that he's been working on in the past few years. Yeah. Yeah. All right. So any questions about like the fundamental things of yeah. Oh yeah. So we were experimenting with emergency response system at Safeguard, and we're experimenting with this. Maybe we'll use it, maybe we won't. But the main thing is we have information, location information coming in all the time. Or if there's an event, like an emergency, we can then, instead of having when a location comes in and we want to take an action on it, like for example, depending on where you're at, we're talking about there's like features where you might want to prescribe to a user based on their location, different settings for their safety equipment. So if they move into a zone, and we instead of having to go like look in the database, we can have these zones that live, and they could subscribe. And when every location, when someone comes in, we could publish a location, stream it, and do logic in memory, and instead of having to like write database. And then we could also do, there was another thing is we have to keep track of workers. When was the last time they connected with their cell phone? In terms of like, we do like a ping, like, are you still there? Did they go out of network coverage? And so that is kind of a cron job type thing, right? You have to check on everyone or check on where they were last. But if it's in memory, we just have all the active workers, and you can add, you can do another feature we'll talk about, that there's timers and reminders. And so you just get this in memory option to, you can write, instead of writing like logic that has to go through all your active users, you can write logic about one user, and it's going to run just about that user. So you can go worker in the field, and then you have a timer that just always checks on the single worker. It's pretty cool. And there's no database stuff except for like if something changed, like, oh, the timer a lot, like, oh, we didn't get a new message in to the worker. All right, now we'll save to the database that they're in a new state, like they're disconnected. We should do something else. Yeah. So that's the big idea, that you can change your mental model for how, I think I have a little thing about that. I thought I had like a, oh yeah, different mental models. So you could think about identity and state behavior versus like services and endpoints. And then I guess I could talk about those timers and reminders. Is that relevant? Yeah. So there was an example, like we had that with the auction. The auction is live, our auction grain. We might want to do, what is that? Okay. All right. So at the end of an auction, instead of having to figure out when an auction ends by looking over our database for all active auctions that are ending soon, or having some sort of other trigger in our database, we can do an end of auction reminder. Reminders are persisted, so you can choose how to, again, there's grain persistence, then you can get a reminder persistence. And I think reminder, you can just, it gets persisted to table storage. So if a silo goes down, reminders will still fire, wake back up those grains that should respond to that reminder. So let's say the auction, no one's bid on it for a long time, so it's been retired, it's out of memory. This reminder will still fire at the end of the auction, because we can, I believe on activate here, there's a, you can ensure that your reminder set, you set a due time and a name for the reminder. And then that reminder gets set. I believe this keyword needs to be used because, what, like, this is funny, watch, you won't, Kevin might know this. And I think it's all because it's the code's generated. I haven't talked about that. But a source generator generates everything, but then also this is an extension method, so I can't figure out why you have, it's an extension method. Yeah. Okay. Perfect. Not implicit this for extension method invocations. So that's why we have to do that. I knew Kevin would be able to answer that. Yeah, so you can register, update the reminder. This will create the reminder or override, or create it or override whatever is there for that current reminder. So we're just setting at the due time, which is when is it a time span? What do you pass in? Yeah, time span. So we're just getting a time span based on now and when the auction ends. And we create this whenever whenever the auction gets activated. So we're just like, all right, it gets activated. Let's make sure we have that reminder set. Yeah, yeah. If the end ends in 3 minutes, we're testing, and it'll fire. You have to inherit or implement the iRemindable receive reminder. Reminder comes in. You can check on what type it is, switch statement, do whatever logic. This is just, all right, if it's end of auction, let's go look who's the biggest, who won it. And of course, you could do whatever you wanted here. Now you know who won it. You could send out emails. You could publish that the auction ended to another service, and it would start doing its thing. So instead of having to go at the database, reminders are a pretty powerful tool of Orleans. So that was one of the things that I was interested me in at first. Timers are very similar implementation, but they're not durable. Or sorry, like, yeah, they're just in memory. So you'll use those for more frequent things. So let's say you had, I don't know, some game, I don't know, some game and you're storing state for like a game, and you need to do something for every player that was in this certain state at this certain time every few seconds. You could have a timer for 5 seconds or a second or even a sub-second. And whenever that timer fires, it's going to call it with a message. It's just the timers and reminders both call using the message system as well. So yeah, exactly. Yeah, yeah. The actually, don't quote me on timers being done through the messaging system. They might be handled differently. I was trying to so you might not get single threadness. Just double check on that one. For sure with reminders though, they call through the message system. Yeah, if you have a timer, that'll keep it alive. Yeah. 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 So then you have, yeah. So you probably want to have, from implementation standpoint, good thing. Timers will keep your they keep your grain alive. So you probably want to have a way to get out of the timer, so you don't just have infinite grains going for whatever reason. So other things. These are. We talked about a little bit about the grains being how they're the source generation is done on them. Specifically on the state, but also like anything marked with grain, I believe. If you can create grains without having to use inheriting from grain, but then you just have to tag them with a specific attribute. But if you inherit from grain, it knows to go through the assembly, and it generates all the basically that remote control code that is needed. There's a lot of source code generation, and then when you create state, auctions do not have a model called that. That's probably just like, oh, the state, is the state in here? Where's the auction state? Even bothering searching. All right, here we go. So you put the generate serializer, and then this is used for serializing the stuff to and from the database, as well as serializing it in terms of network. And the details about the network, I believe it's like just using TCP and some protobuf stuff. So it's supposed to be fast. And then you'll notice you have to put ID on here. And the ID is important for serialization. I should know the exact details on it, but one, like versioning, I think is important with it. And then also just like the serializer, that's how it works. It's like, it's supposed to be like, somehow it uses those numbers to make sure it assigns it to the right spot when it repopulates it on the other side. Yeah, I believe that's how it would behave. But yep. So you got to make sure you have your grains marked, the grain state marked to be serialized. One thing that I found a little frustrating right now with the current setup is like if you just follow the docs for setting it up, like there's this example, like here's how you set up your application with Aspire. They talk about having a nice separate project for your grain interfaces and a nice separate project for your grains. So you can, because you can do unit testing, I'm not going to cover that, but there is unit testing. So you can even unit test a silo and all these behaviors. There's a little bit of development documentation to how to do that. So it's nice if you have your interfaces in one project and then your grains in one project. I could not get the grains in another project because you need it. Kevin would know it immediately, but basically it was an assembly issue and I couldn't figure out what I needed to do with my project file to allow it to make sure it would scan the other one. So my silo right now is where the grains are living. So I wanted to put them in this project, but it wasn't, I couldn't follow the example. So instead the grains are just living in that same silo project, and that works because it's able to find it in assembly. So you might have difficulties with serialization and assemblies. Yeah, exactly. Yeah, yeah. Yep. Yeah, the silo project. So yeah, that's a good one. That's a good one. And then some other things oh, we didn't even talk. I didn't realize how long I could talk for. Let's see. So let's just cover probably let's just show how easy it is to configure. So you used to have to configure. You had to all the IPs, make sure you could do the hosts. You'd have to manually increment IPs for every silo. Now you can just go to now it's really simple. I'll go to the Aspire docs in a second, but you can build your app host with Aspire. So now the recommended way to do Orleans is with Aspire because it just makes everything easy. You can, depending on what you want for your persistence, the defaults they just showed in the example are blob storage for grain state, tables for clustering. That's where clustering stores the information about the silos and the membership. And then, yep, so you can add those items. Then we have oh, yes, yes. Yeah, 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 yeah. And then typically also the keyword default is used for all the other automatically configured through Aspire settings for like other providers. It'll just be default for each type. So first we're just setting up that storage, what we're going to use so we can have persistence of the grains, we have persistence of our clusters, or cluster, usually it's just one. And then we're going to configure our cluster, and that is doing, well, there's lots of, it's doing a lot of stuff, but it's really great. It's basically configuring all the networking so that our cluster is all ready to go. And this is doing the configuring the networking for the cluster as well as configuring where it's going to get persisted. And then our silos, we can just pass in right here. It's just magic. Our silos already know what to do as soon as we pass in our Orleans instance here with the reference. And so the silo project knows exactly how to talk to the cluster and then talk amongst each other. And then, yeah, so it's real simple just with Orleans. Yeah, so list the grains, and then I'll go to that one. Yeah, let's go to the silo project. Here's the silo project. Commented out some things. I should have just erased them, but focusing on, this is all you have to do is use Orleans. You don't even need the dashboard portion. I'll show you that in a second. But you just do use Orleans, and as long as you use the keyed right here, use Orleans will have those dependencies for the grain state and the clustering that the silos each need to use. So very, very simple. It's kind of, and so I'm like, oh, this is simple. But previously, you can look at it. I'll show you the old way. It's just like you would have to on this one pick the IP of your cluster, and then you have to type it in. And also, what's the IP I want for my silo? But with Aspire, it's all automated. So good. Mm-hmm. There is a section about authorization, but I'm not too versed in it because I haven't done the. But I imagine you can do a lot of things like that. There's and then to that effect, you can also just use the console SDK, and you can have a silo just running as a console type app. So yeah, no, no, you can do either one. Yeah, but if you want those web application features, then go ahead and use that. And specifically, I wanted the add dashboard feature, which uses the web application, the SDK web SDK, because it exposes a bunch of other networking things. So that was a really good question. Yeah. Yeah, at first I just did a console one. I was like, wait, why can't I add the dashboard? Oh, yeah. So, yep. And then this is cool. If you have a client, so we've configured our silos, we've configured our cluster to know about our silos. So every time, or sorry, and our silos to know about our cluster. And then we have the API service here, which is an example client that I have. And all you have to do is with reference Orleans as client. Call this nice extent method here. And magically you get an Orleans client where we were showing where in the program API service, you can just add a use Orleans client. You don't even have to do this use dashboard thing. You just go use Orleans client and magically you get the iGrain factory dependency whenever you want. As with other, other things you can use with it. So yeah, this is like, I think it's been a year or so they had that Aspire stuff, but with version 10 that just came out like 2 weeks ago. As I was reading, I was like, there was no documentation. And all suddenly there's like a bunch of documentation. Like I feel like a lot of things were touched in the past 2 weeks. So really exciting time to be like looking at it. It's changing, it's shifting, but it's also just getting a lot easier to use as I was. So thanks, Ruben. Yeah, so that's we learned some good insights, good questions, Dan, about setting it up. But yeah, that's how it works. And then I was just going to show the other dev feature that's really cool. So I have them all running here. Oh, there's only one silo running. In the example, they say run with 3 silos, but the other 2 silos will always fail. So I just figure it's an IP thing. I don't know. I didn't delve into it, but I think yeah, only one replica works. So I know if you, maybe it works in a Kubernetes situation, but when you're doing it locally. Huh? Uh-huh. Yeah. All right, so we're talking, it's a .NET Dev certificate issue, and you can't run duplicate containers. Open GitHub issue. All right, Kevin had the answer for that one too. Excellent. So yeah, you can run one silo, which is fine for testing. So, but one of the cool features is, as you saw, I had in here, there's a dashboard feature. To use the dashboard feature, you turn it on in your silo program. Just add dashboard. All you have to do. This is a new. They just added it. Like it wasn't there 2 weeks ago. I swear. Yeah, so they got this nice dashboard. Well, it was actually this was a project by another project by another developer, and he built it. So it's been there for a while, but then they merged it into the repo, and then for a while it just I didn't for a few months or a year or what it didn't sit. It wasn't like in a nice package, easy to use. And now it is with version 10, and so you just enable that there, and then you can co-host it. So you could do right here. I think what is it? App dashboard. Yeah, so you could call it here, but I instead that would expose this silo would expose an endpoint that you could go interact with the Blazor app. But instead I put it on I did it on the client app, which I thought makes more sense. So they say you can do either way. So yep, map Orleans dashboard. That's all you gotta do. And then I just need to go show you guys that because it's kind of a cool feature. Oh, there's a counter grain running here on the home page. So every time you refresh it, it's gonna give you count going up. Amazing. No, so dashboard. Dashboard has a lot of features. So if you get into the nitty gritty of it, there's a lot of metrics that are being collected, and they get collected via grains. So there's pub and sub going on in the background that you have these default grains. There's a management grain, counter grain, that's my grain, and the dashboard grain where everything's getting published to. And you can see right here, you can see your throughput, right? Latency, exceptions, how many activations do you have of something. So yeah, it's pretty cool. Yeah, it's pretty. Yeah, and then I'm not. No, so there you go. It's pretty nice little thing to kind of see what's going on in your entire cluster and diagnose any issues, pain point, like which ones are struggling, what things you might have to refactor. So it's pretty cool. Live demo. I might be able to see here. I mean, just for effect, I think I had thought I had right here. Cool. So there should see another activation immediately there. In my auction grain, I just placed a bid. And so that bid was handled in, of course this is localhost though, but it handled really fast. Normally you would have to, right, go to the database, right, to get that information. Instead, it's right here. Yeah. 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 So I can spin up another auction probably by just typing in another auction. Auction 12. We'll place a bid on auction 12. Now we have 2 auction grains. So dashboard is an awesome feature. I'm looking forward to learning more about that. And yeah, is there any, like, I guess the other key takeaways, I'll just leave with one key takeaway, because there's other content I do have, but well, I thought it was yeah, that it's really fun to work in it because I like just thinking about the actor model is really fun to think about your business problems with, and the features that you have with the persistence and memory. You could do, you don't have to, you can focus on smaller parts of your business logic rather than like, oh, I need to go do something like where you have a service that checks on a worker, right? Or I can call into that, or a worker service. Instead, I can interact and just create a logic around a single thing. And but with that, I think what I was getting at with this is sometimes let's say when the auction finished, we used the email service. we can publish an email to the email service or send a message over, and it'll do its thing. But then you have to realize or your email grain that you would normally implement as a grain. So instead of a search, you're implementing as a grain. So you have this email sending grain. You could have, or here we're talking about push notification. So we'll just say push notification grain. You can do a singleton pattern by just using always the same constant for the ID. So it's a common thing. You can do that. But let's say you had too many auctions. You don't want to start pumping all this stuff through the same thing. Just think about logical partitioning, where auctions in Washington State use the Washington State push notification, or I don't know, some other thing in your business. You can figure out how can you partition, and so you get a new instance. So you have a grain that is maybe closer in terms of its location, as well as you can handle more concurrency. So you think about it makes you think about services in a different way too, because you can yeah, because you can go like, oh, I want, instead of injecting this, the dependency injection is a little different, because it's kind of, you can think about identity instead. So grain identity is a scaling primitive, not just an ID. That's the kind of the concept. And goodies. Yeah. No, tell. Okay. Yeah. Success message brought up sharding in Elasticsearch and how you can use a different identifier to make sure things go in a different location. So you have to be smart, yeah, just partitioning strategies. Good point. Okay, anyone interested in streams, or are you guys bored of me? I really appreciate all the great questions. It's been fun. I guess we'll just end on stream, on the stream feature. So we talked about, inter-grain messaging, grain-to-grain messaging. Streams allow you to decouple from your, of course, it allows you your subscriber from the publisher. So and with Orleans, different than just like a regular stream. If you think about like a stream processing thing, you might use like, I don't know, Azure function, you might use whatever, various things, or some sort of service that is watching a stream, and you have to handle it that way. But in this case, you can have thousands of things that subscribe to the stream, and it's a lot easier than a bunch of microservices watching a stream or a Azure function. So I think that's what they get excited about. Ruben talks about it in that way, like it's kind of free form computation, fine grain, because you can just be like, I don't know of any, I don't have any good contrived examples, but as you could think, you have one thing and an event happens there, it can publish to a stream, and all these other entities that you have can respond and do their own independent logics. So you have a way, instead of a code control flow that is limited by how many microservices or stream watchers you can spin up in terms of a more traditional framework, with Orleans, you can just have, you can create, you could think about, and with stream management becomes a little bit more extensible, I guess. Microservices, right? Yeah. Yep. Exactly. So a topic, Seth brought up topics. It's kind of similar like that, where you can publish and you're guaranteed that all of the grains that are subscribed to that topic, that queue, the stream, will get that message at least once. Yeah, so how does this how does a stream interact with, or how does a message get to a grain that's coming from a stream? It'll wake up. So if a grain is not activated, it'll be activated when a stream publishes something. So that's the handy feature there. And the streams are the durable portion about streams is that if you had a bunch of grains processing, or sorry, normally the typical in memory one is that the streams are on the silos. They're in memory. And then so if you lost a silo or a cluster or something like that, you would lose the messages in the queue. But when you use a stream provider, durable stream provider, your system comes back online, continues processing all those messages. Yeah, so you can get really inventive and probably trip yourself up with streams. But I think it's a pretty cool feature. So that I have like just a brief example like how that looks here. Can I make this bigger? Yes, it's probably an Electron app or something. We're gonna go back to erase that. Check out that. And if you wanted to add streams, you would go to your app host and you would add streaming with queues. And you would add a pub sub store with grain storage. And this is kind of cool because this keeps track of which grains are subscribed. So you can add a pub sub method here. Else, I forget how the details, like if a grain, you won't keep track of what grains were subscribed. And then the issue there is they won't be reactivated if your silo were to fail. So you use a pub sub store that just keeps track of every grain that is currently subscribed. So you want that for resilience. And then with streaming, and then you pass in your Azure Queue Provider key and the queues with reference with the queues into the silo project. So now it can have access to the queues. Then in the silo project, you do need to add. This is where I was getting tripped up. I'm not sure which ones actually are needed. It's like trying to get it to work. But Orleans.streaming, do need that. Streaming.azure storage, and then possibly aspire.storage queues. That one may not be required. Or it might be required actually for the program to get that. I think it's needed for this one to add Azure Key Service Client. Yeah, that's why that's needed. Yeah. So it comes right in, and that's what you could do. And then I guess we'll look at like I think I created an example I had was like on the auction grain. We have a bid stream, and it's scoped to the auction, so you can have something subscribed to. Not getting bigger. I guess it doesn't let me get this bigger. So let's just go over to VS Code. We should have our stream. Oh no, it's because I haven't saved these. That'll do it. I think that's. Now we should have some new stuff in here. All right. All right. So you can get a stream from the stream provider in the on activate. This is a common place to subscribe to. So this one's subscribing to. Or not subscribing, it's getting an instance of it or a reference to it so that it, not instance, reference, so that it can publish bids that come into the auction. This right here is the method for getting the key that's associated, or the ID that's associated with the grain, so the auction. You call this for ints and GUIDs. You call this one, I believe. And so you just have to know it because you can call get primary key, but that returns, I believe, a string or a GUID. This one returns the GUID representation. Yeah, so the get primary key does a GUID by default, so you have to know what you're doing, because I believe like my auction grain is supposed to be an integer one. So that is something that's kind of interesting you have to pay attention to, is that I think this, I don't know if it fails, but I imagine it fails if this method get primary. So yeah, the stream, and then there's a fraud grain. So every time, well, this right here is spinning, ensuring that there's a fraud grain that is activated, and it'll get initialized to watch this specific auction. So we're just calling to create a reference to a fraud grain because we passed in the key to the auction. Basically, it's going to be having a fraud grain for every auction grain. Very contrived example, but the idea is that when we place a bid, we can where's it at? We're not seeing the code here where it's actually calling the stream. Where's the bid stream being used? So maybe this is, oh, there it is. Oh my goodness, I missed it. Right here, you call the on next method here to publish an event to it. And so we're putting the bid event in there, and that means that our auction grain, our fraud detection grain will implement an on next async. And when that gets called, we'll get that bid and we could do some action on it. So very contrived example, but you can set up streams. And yeah. Any questions about that? I feel like you guys would just let me keep telling you about this and then not tell me this is getting boring. but the yeah, so go check out the Microsoft Learn documentation. There's a bunch of examples that are cooler than the ones I have. Talking about just kind of use cases with it. Some of them are just limited and they're really easy to grok. Some are more complex, but I think it's if you find yourself paying too much for a database, or see that the actor model would help you, write your code more efficiently, or just have contain, and then I think Orleans is a really, really cool platform that's getting going. And I'm excited to see how it gets even more developer friendly going forward, especially with the Aspire improvements. So unless there's any more questions, I really thank you guys for the opportunity to practice some speaking skills, and for not throwing anything at me, and yeah, so yeah.